Have you ever been swimming in the ocean and accidentally swallowed a mouthful of water? Yuck! It's so salty. But have you ever stopped to wonder why? Why is the great, big ocean full of salt, but the lake you swim in during the summer isn't? Well, get ready, because we're about to dive deep into one of nature's biggest mysteries. It all starts with a single, tiny raindrop. Imagine our little raindrop, let's call him Drip, floating high up in a fluffy white cloud. This cloud is just a big collection of water vapor that has evaporated from the ocean's surface, pulled up by the warmth of the sun. As the cloud gets heavier and cooler, Drip and his friends begin to fall back to earth as rain. This is the beginning of the amazing water cycle. Now, our raindrop, Drip, doesn't always fall directly back into the ocean. Most of the time, rain falls on land. As Drip lands on a mountain or in a field, he starts a long journey. He flows over the ground, seeping into the soil and trickling over rocks. And here's where the magic happens. The rocks and soil all over our planet contain tiny little particles called minerals, and a very common one is salt. As our little raindrop flows over these rocks, he acts like a tiny solvent, gently dissolving and picking up these microscopic salt particles. Think of it like Drip is carrying a tiny backpack and collecting little souvenirs along his way. Soon, Drip joins a tiny stream, which flows into a bigger creek, and then into a mighty river. All along the way, he's joined by billions of other raindrops. And guess what? They are all carrying their own little backpacks full of salt minerals they've picked up from the land. For thousands, even millions of years, rivers have been acting like superhighways, constantly carrying these tiny bits of salt from the land on a one-way trip to their final destination, the ocean. So, all this river water, filled with a tiny amount of salt, pours into the massive ocean. You might think, well, if it's such a tiny amount, how did the ocean get so salty? That's a great question, and the answer is all about what happens next. The sun shines down on the vast ocean surface, and just like at the beginning of our story, the water heats up and evaporates, turning into vapor and rising to form clouds. But here's the crucial part: when the water evaporates, it leaves everything else behind. All those little salt particles that Drip and his friends worked so hard to carry are too heavy to evaporate. They stay in the ocean. This process has been happening continuously for billions of years. Rivers bring in a little bit of salt, and the sun takes out only the pure water. It's like a giant salt collecting machine. The salt arrives, but it has no way to leave. It just accumulates, year after year, century after century, making the ocean saltier and saltier over time. It's a true one-way street for salt. Now you might be wondering, okay, that makes sense for the ocean, but what about lakes? Rivers flow into lakes too, so why aren't they salty? That's because most lakes aren't the end of the road. While rivers flow into lakes, most lakes also have an outlet, another river that flows out of them. This exit allows the water, along with the dissolved minerals it's carrying, to continue its journey. The salt doesn't get a chance to build up because it's constantly being flushed out. The Great Salt Lake in Utah is a famous exception because, you guessed it, it has no outlet. Water flows in, evaporates, and leaves the salt behind, making it incredibly salty. Just like a mini ocean, the amount of salt in the ocean is truly mind-boggling. If we could somehow remove all the salt from all the oceans and spread it evenly across all the land on Earth, it would create a layer more than 500 feet deep. That's as tall as a 40-story office building. This high salt concentration is what makes it so easy to float in places like the Dead Sea, which is one of the saltiest bodies of water on the planet. The water is so dense with salt that it literally pushes you up to the surface. You can actually see this process for yourself with a simple experiment. Take a bowl, fill it with some tap water, and stir in a few spoonfuls of table salt until it dissolves. Now, just leave that bowl in a sunny spot. Over a few days, you'll notice the water level getting lower and lower. That's evaporation at work. Eventually, all the water will be gone, and what will be left behind in the bottom of the bowl? A crust of salt crystals. You have just recreated the very same process that has been making the ocean salty for billions of years, right in your own home. So, why does any of this matter? Well, understanding the ocean's saltiness is incredibly important. For one, we've developed amazing technology called desalination, which does the exact opposite of what rivers do. Desalination plants take salty ocean water and remove the salt to create fresh, clean drinking water for millions of people in dry coastal areas. It's also why the ocean is home to such a unique and incredible variety of life. From the smallest plankton to the largest whales, marine animals have special adaptations that allow them to live and thrive in a salty environment that would be impossible for freshwater fish to survive in. So, there you have it. The next time you're at the beach, you'll know the secret behind that salty taste. It's all thanks to a journey that starts with a tiny raindrop, travels across the land, and ends in the great, big ocean, where the sun and time work together to create the salty seas we know and love. What other big science questions do you have? Let us know in the comments below. We'd love to hear from you. And if you enjoyed this journey from the clouds to the sea, don't forget to hit that like button and subscribe for more amazing science adventures. Thanks for watching.